So in my previous video, which was a few days ago, I did the first part of this problem. Actually, I did do a video on the second part, but I realized it was too long, so I'm just making this quite a short one. So just a quick recap of what we've done here, and this is the picture of the system. Initially, it is compressed by the delta L, which in the second part is given to us, and when we release it, it is jumped off, and it has an extension of D in the final state, and this is the final state when this lower block is just about to jump off. And I'm calling this height total height h, and this line here, this line is the natural length or the rest position of the spring, and at this position, the final position, it also has some velocity. Let's call that v. Okay, so and I've written a definition of the velocity of the center of mass of a two-block system. So I'll make a video on that in my future videos. To find this velocity and this d, etc., actually we know d, and if this block is just about to jump off, then if this is this block here, then it has its own weight, which is the mg, and it has the spring force, which is the spring constant, which is x, times extension, which is d, and it has no normal force because it is just about to jump off. So these two must be equal because it is not moving anywhere just yet, so xd must be equal to mg. So from here we get that d is equal to mg by x. Okay, now to find this velocity, we just need to conserve energy from here to here, and I'm calling this line here, the initial position of the upper block, to be my reference line, which means that the potential energy at that point I'm defining to be 0. Okay, so above that it'll be positive, and below that it's negative. Okay, so what is the initial energy then? The initial position is this, and the initial energy is just the spring energy, because there is no kinetic energy nor there is any potential energy, because we just defined this line to be 0. And you might say this block here has some potential energy, but I want you to see that in the final state also this is at the same position, right? So you can write that energy, but it'll kind of cancel out, right? Okay, so initial energy is just the spring energy, which is 1/2 times the spring constant, which is x, or the stiffness, which is x, times the compression squared. Compression is delta L squared, and that should be equal to the final energy. And the final energy is just this velocity. This block has a velocity of v, so it's half mv square, and it has also gained some potential energy, which is mgh plus, and there's also the spring energy, which is 1/2 times the extension, the spring constant, which is x, times the extension squared. Now the extension is I assume that it is d, so it's d squared. Okay, so let's substitute the things that we have here. Okay, so delta L is 7 mg by x. So if you substitute 7 mg by x in place of delta L, you'll get 49 m squared g squared over x squared, but we have an x here, so we'll get 49 m squared g squared over 2x, right? And that should be equal to 1/2 mv squared plus mg. And I also want you to see that h is nothing but d plus delta L, right? That is, you can see that geometrically, so it is d plus L plus 1/2. If you substitute d here as mg by x, we have that here. So if you substitute it, you'll get m squared g squared over x squared, but we have an x here, so you get m squared g squared over 2x, right? So let us bring this to the left hand side. we'll get that it is 49 minus 1 is 48, but we have it divided by 2, so it becomes 24m squared g squared over x is equal to 1/2 mv squared, and d is mg by x, and this is a delta L, sorry, this is a delta L, and delta L is also given to us, 7 mg by x. So 7 mg by x plus mg by x, so that is 8 mg by x, so it is mg times 8 mg by x. So from here we can solve for v. So let's see, we can cancel out one m here, that goes away and that goes away. So on the left hand side you get 24 mg squared over x. On the right hand side you get 1/2 v squared plus 8 mg squared over x, right? And if you bring it to the left hand side, you will get 16 mg squared over x is equal to 1/2 v squared. So this implies that v squared is equal to 32 mg squared over x. So we get that v is equal to, the square root of 32 is I believe 4 root 2, and actually I'll just write it like square root of 32, so it is g root 32m over x. So that is our velocity, and you can call that v1 because it is the velocity of the first block of the upper block. So according to this equation that I have here, which I'll prove on in my later video, what is the velocity of center of mass then? What is the velocity of center of mass? The velocity of center of mass will be m1 v1. m1 is m, so it's m times v1 plus m2 v2, but v2 is 0. Remember, this block has no velocity, so that term is 0. It disappears, over m1 plus m2, but both the blocks are of the same mass, so it's 2m over 2m. So this is nothing but v1 over 2. If you substitute it here, you get g over 2 times the square root of 32m over x. 32m over x, right? Okay, so that is the center of mass's velocity. And now we can use the kinematics equation that we used to learn in our earlier days. So we know that v squared, let me do it in a new color. So we know that v squared is equal to u squared plus 2as. So v squared is the final velocity squared, but the final velocity is 0, right? And just read the question, to what height h does the center of gravity rise? So when it rises to the maximum height, its velocity will be 0, right? So v is 0, so it is 0 equals to, initial velocity is nothing but the center of mass's velocity, and we have got to square that. So if we square this term here, let's see, you got 32 over 4, which is 8 g squared m over x plus 2 times, now g is negative g actually because it's kind of slowing down, so I take that as negative, or you can visualize that as vectors. So, and s is what we have to find out, so I'll just write it as h, and from here we can solve for h. So h will come out to be, let's see, it's 2gh, so you gotta divide by 2g, so it is 8g squared m over x times 1 over 2g, which will come out to be 4mg over x. There you go. That is the final height to which the center of mass of the system will rise. And I didn't check my answer because I don't know if I did some silly mistake or something, but I'm pretty sure I did the right thing. Okay, so yeah, that was quite long, but yeah, it's very interesting. It tells us how all the concepts like center of mass, energy conservation, and everything else, the spring force, and whatever else concepts that we have learned, kinematics, etc., can be combined in one question like this. So this problem was from Erudov, which is a great book for such problems if you want to do some higher level problems, which for some entrance exam or something. Yeah, that's pretty much it, and I'll see you in the next video.